Geometric Optics 8, Concave Lenses. A concave or diverging lens causes parallel paraxial rays of light to diverge away from a virtual focus. To give you an example, let's draw a concave lens now. So a concave lens looks as something like this. Okay, let's go through the anatomy of a concave lens now. So a virtual focus, the virtual focus is the point where rays of light diverge away from. So if you're looking in this direction through the lens, the virtual focus will be at some point on the same side that you're viewing from. Okay, so this is a virtual focus because the rays of light don't actually converge to this point, they diverge away from this point. Okay, we call this F. Next is the principal axis. This is the line through the virtual focus and the midpoint of the lens. Okay, and then in addition we have the focal length. That's the distance from the lens to the focus. Okay, that's F. And then lastly we have the optical center, and that's the center of the lens, and we denote that by O. Now, images that we see in the lens, so let's say we have an object right here. Okay, so if an image, for rays of light that enter parallel through the lens, okay, parallel to the axis, these will diverge away from the focus. Okay, so we're going to have an imaginary line, and from this point, the ray of light will diverge or refract away from the focus. And in addition, similar to convex lenses, rays of light that enter the optical center or go through the optical center do not refract. Okay, so a ray of light that goes through the optical center will just go straight through and will not refract. Now, where these two lines converge on this side of the lens is where your image will be. So this would be your image.